Hello and welcome everyone. We're really excited to be here now in the first part of 2024. So we have a lot of emergent technologies, a lot of new challenges that are coming from AI world. So we have retrieval augmented generation, semantic data chunking, we have re-rankers, we have hyper-personalization. These are a lot of buzzwords that you constantly hear either on social networks or within the products that you are working with. So this is where we stand now in the first part of 2024. And here at Cycling, we are excited about exploring new AI possibilities and tackling the most complex technological challenges. Now, here is the agenda today, and I have here with me my very skilled and experienced colleagues in a lot of technology and they have a lot of experience working with AI and AI products. So during today's presentation, I'll be introducing some concepts and also passing from time to time the microphone to my colleagues. We are going to discuss today about retrieval augmented generation mostly, and what is it, what is the role of retrieval augmented generation. Then further, we are going to start from explaining from the fundamentals of RAG to how to actually build it using different programming languages, such as Java, Python, and JavaScript. These are the use cases that we are highlighting today. And we will start from the ground by building a small LLM wrapper. So basically, an LLM wrapper, you will see it's something that you probably are familiar with. It's a way really to interaction with a large language model, but without too much context. Then further, we will find some ways how to use our applications, how to use our MVPs to deploy either in our local environment, in a cloud environment such as AWS cloud or Azure cloud platform. And by the end of the presentation, I'm going to invite my colleagues to have a small discussion about concerns that AI brings nowadays, and about the challenges that we are facing as a software development company, and how we tackle these challenges in terms of QA, data privacy, data security, and more. So how are we dealing with this, and how our partners are facing issues and asking for support, what we do in this regard, and so on. So initially we will have more practical presentation. So please expect about 90 minutes of technical presentation and discussions. Probably the first 75 minutes, 60 to 75 minutes, it will be more practical with more live coding and showcasing different technologies, different technology stacks. And by the end, we'll have more in-depth discussions about new challenges that AI brings into the scenes. So just to highlight quickly the technical map of this session, we are going to work with Java, Python, and JavaScript. So here we have specialist programmers in these three programming languages, and of course with their ecosystems. In terms of databases, we are going to use pgvector and Quadrant. Of course, these are vector databases. We also have built within our applications other more traditional types of databases, but they are not the scope of today's presentation. We are only discussing in the context of RAG, so that's why we need these vector databases. And in terms of infrastructure, we are going, as I mentioned, to discuss about hosting on our on-prem environment, whether if it's a local environment or if it's a virtual machine, either if it's Linux, Windows, or macOS, it doesn't matter. So we will discuss a bit about portability. We are discussing about migrating and installing this application type of RAG on cloud and AWS and Azure, and we are going to use for the increased portability, we are going to use Docker. Now let's have a quick introduction and a really small practical demo on what is a RAG, right? So as you can see in this image, RAG is basically a system that essentially it correlates what user asks. So it's a query from user, right? It correlates that query with a data chunk, and it brings the most semantically similar part of the data from the database, right? further, it is passing this data to the large language model and it's retrieving an answer. So this is basically a retrieval augmented generation system. It's like you are discussing with a large language model, but sometimes large language model doesn't know everything about everything, right? So sometimes we are talking about private data, we are talking about very specific context that only us as data owners, we can control them, right? So in order to discuss and to have this interaction with a large language model, we need to enhance a bit our query and to put it into a given context, right? So this is like the naive architecture of a RAG. It's just taking the prompt, either sending to the large language model and getting back the answer, or taking some more context, adding to our prompt, sending to the large language model, and give a better answer, right? This is the scope, to get a better, more in context answer. And as a Java developer, I'm starting to build now a large language model wrapper just to show you, just to demonstrate to you how we can do that, how we can discuss with the large language model. We'll deploy this locally, very easy. So we have only like under 200 lines of code. And of course, we'll integrate a third-party client, so we can also have a visible result, right? Let me please switch to my IDE. And actually, I will start with a third-party client. So the third-party client, it's a Telegram bot. So when I'm simply initializing the chatbot, I'm pressing start button here, and now I have the discussion ready. If I ask hello here, of course, my bot doesn't know to answer anything. It doesn't actually exist yet, right? It doesn't exist until I go to this part of code. And let's start exploring what do we have here, right? So very, very quickly, we have a knowledge base where we hold a default answer. And for any question we will get from our chatbot, we will basically retrieve that default answer, right? So okay, one sec. I think I have some lag, guess. Okay, let me start the application. I'll start in debug mode because I want to highlight where the code stops there, and you need to see how we're interacting immediately with the large language model, right? Okay, so when I started the application, it's trying to generate this reply, right? It's a very simple method. We have 4 lines here, and of course, I'm trying already to get a response from the LLM, right? But initially, we don't want that actually. So what we want to do is to restart the application and to answer with something from our knowledge base, right? So the knowledge base contains a default answer, right? And this default answer you can clearly see here. I'm typing the hello again, right? And going back to my application where my breakpoint stopped, right? And it is okay. It is now. I think it's still initializing or something. One sec. Yeah. Maybe let me restart the application. Okay, so yeah, for some reasons, have a lag here. I'm trying to switch the screens, and probably you will see with some delays, but on my side, it works smoothly. So I'm trying not to switch very fast between the screens, right? So here we have the first answer is, I'm a simple bot. I can answer only based on data that I was taught. I'm still learning, right? So this is what we get from a default answer. What we can do additionally, right? So additionally, we can replace this knowledge base, the default answer from the knowledge base. We can replace it with an LLM wrapper, which is basically a class that is calling a chat client from OpenAI and is sending this prompt. Initially, you will see this prompt. It's just our text, our query, right? And then we can even enhance that with some context, right? So now I received some, because I had that lag, I received some messages from the past. I can start again, right? And now you can see that already I'm discussing with a large language model, right? How are you today? Okay. I'm just a computer program, so I don't have feelings. Okay, so this is what the large language model tells us. Now, if I'm trying to ask something more generic, tell me something about Cyclone. Okay, let's see. So we have that Cyclone is a digital solution company. All we did here, it was to take this prompt and pass it to the large language model. It's that easy. And we built a large language, LLM wrapper, right? Now, if I want to bring a bit more context here, I can ask, please answer using sophisticated words, as you would when writing to a scientific paper, right? And then if I'm asking again the same question, then we will see something that it's extensive experience on some new keyword that we didn't see before, right? Maybe it's not that obvious, but what we can do is again switching the context and ask the question again, but now it will answer as I'm discussing with someone that has 7 years only, right? So tell me something about Cyclone. Let's see if the application initialized already. Okay, still loading. Let me restart the app. Okay, it's actually running now. Yeah, and now I can, yeah. So Cyclone is a company that helps other companies make cool things like websites and applications. So this is something that we do not control, but we can influence the way how LLM answers by changing the context, right? So this is RAG, what RAG is about. Just changing the context, adding some more context to our prompt, and then getting different answers, right? And I did here a very naive, a very simple RAG. And you will see later this this application has under 200 lines of code, so a very small Java application. Now, you clearly see that that was run locally. So I integrated Telegram as a chatbot. All I had to do, it was to execute the LLM call and send the prompt with potentially some additional context, right? Now, why do we need RAG? Of course, we need it because it's adaptable, because it's very cheap. It's not expensive, and helps us to expand the knowledge base. So always when we discuss with the large language models, we can keep in mind that it doesn't know everything about everything. This is the key, right? So we want to expand the knowledge base. So this is what I did. The LLM didn't know that I'm 7 years old, right? So I just told in my prompt that I'm 7 years old, and I introduced that at the application level. Now we are starting slowly but surely. We are starting to create an architecture that gives us a bit more interaction with the LLM, right? And further, I'm passing now. I'm introducing my colleague, the expert data scientist Ivan Shelonik, to show you how we can achieve the same thing but with a different programming language, and how we can deploy that on AWS. So Ivan, please join the stage, and I think you can also take the screen. Thank you very much. I will come back soon.
Sure. Thank you, Lucian. Thank you, Rina, for introduction. This was cool. Very, very, very great. So let's start. What I want to say. Today we'll
take the screen. Take the screen, Ivan. I just stopped.
Yeah, sure. I'll show it right now. Just a second. And here it is. Here it is. It's in. Great. Awesome. Today we will deploy a Llama 2 13B open source LLM. It can be any other HuggingFace LLM on an AWS EC2 instance armed with a robust 24 gigabytes of GPU. And using CloudFormation YAML script, we will establish infrastructure for it. We'll pack, build, and run everything as single Docker Compose file, which provides communication between GenAI RAG application with both open source GPU-powered LLM TGI inference and proprietary OpenAI LLM API for comparison purpose. So let's start. And just a little bit to remove this line. Okay, what do you see? You see the AWS console. We're in here, and we'll be required two services, EC2 and CloudFormation. Let's just open it from open it. I want to show that it's empty. Right now, we don't have any running instances, and our CloudFormation has some scripts, but it's not related to what is required for us. Okay. Let's start creating our infrastructure. So what we need to go into our code. You see SK GenAI RAG event folder, and inside we have a LLM Flask RAG AWS folder of our project. So inside we have EC2 deploy LLM YAML. I'm just, unfortunately, I need to firstly to go inside files. Copy it here. We're doing it next. I'm creating any name. I'll explain this YAML file when initializing will be started. Next, submit. I believe I used proper LLM key. Not sure whether I did it right. Unfortunately, probably I need to delete it. I think I forgot to use the proper key. Just a second of time. Next, yeah, LLM key, and I was too fast. Yeah, and we are provided the different name. Right now, it's going to work because it would be inconvenient if we wouldn't be able to get into our instance. Okay, stack is already exists. Let's create the different stack. While this in process, upload, and you can see that how we can even manipulate with it. Let's use stack 2, stack new, stack new, LLM key, and we'll do it one more time. Submit, and yes, everything is fine right now. While it's happening, our infrastructure is setting up. Let's look inside. What do we have? Inside we have our template, YAML template, with where we are specifying our input parameters and our resources. In terms of resources, what we have security group, where we are specifying the ports we want to be opened from worldwide. In our case, this is SSH, LLM inference port 8080, and Flask port 5000. Remember this, it will be required for the future. EC2 instance. As a resource, what I'm doing, I'm taking the G5 XLarge instance, passing security group from above, and specifying the MEI instance I want to use. Probably that's it. It takes around 70 seconds in our case. 17, right. Everything is complete. Our resource is set up, infrastructure exists, and right now we are update our page, and we are seeing our running EC2 instance. Awesome. We have port, we have everything, and this is our G5 XLarge instance. I'm taking this public IP. Close this one. Open comments. I wrote this for you, so you could even reproduce everything that I'm doing right now. What I need again to open our folders. We are right now in the root. Open internal. Copy this public IP. Click. Just want to show you, what I did. I a little bit changed the IP, how it looks like. Echo, public IP. Yeah, from comma to the hyphen. So this is just for convenience to be able to use SSH. What I'm doing right now, I'm running SSH and want through this get into our instance. So we're inside. You can understand it by seeing this textual information at the bottom left of our terminal. I'm just opening the new one tab and probably copying the same in here. I'll explain it. In here, I want to show that, yeah, this is our instance with GPU, right? What we see in NVIDIA A10G, we have 23 gigabytes of GPU RAM, and we can start using it. But we don't have right now our quote, so we need to load it. So one of the way to load it is using git clone, right? But I wanted to do, instead of do not mess with passwords and some other stuff, I just use SCP to copy everything from my local PC through SSH to our instance, providing recursively. So right now, you see this LLM Flask Rec AWS is appeared. It's taken from my local environment. Let's get inside. So we have the same structure as is provided in here. The one problem, we don't have Docker Compose. It will be required for us, so we're installing it, and that's it. So what we have to do is just use Docker Compose up, and everything is going to be set up for us. So weights are going to be downloaded, GenAI application is going to be built, and everything what will be required for us is just communicate with our GenAI rack application from the local. So let's start diving into how it works. Yeah, it's done. In terms of terminal, I close the not used in the future tab. What we see, yeah, Docker Compose. Let's start from this one. Services, what we have? We have Docker Compose file. Docker Compose helps us to orchestrate our images. In our case, one image is going to be for our GenAI rack application, which is going to be handle both OpenAI and open source Llama 13B LLMs, and LLM inference service, which is going to be just download. This is just our open source LLM inference, which we're going to communicate. And this is our Llama 2 13B. So what we're using text generation inference from HuggingFace. Loading it, specifying the runtime. We want to use NVIDIA and use GPU because we have GPU. Why not use it? We are using Xllama backend for our side to a little bit decrease latency and provide faster responses. We have specifying some volumes and our command like model ID, which is our Llama 2 13B ChatGPT-Q quantization, revision, port, some information about tokens, how much tokens we want to use. In our case, it's one concurrent request, but we can handle tons of concurrent requests, and it will be required more GPU for us. So we're specifying anyway CUDA memory fraction. In our case, this is 90% of CUDA. And in terms of our rack application, this is our Docker file, Flask. We also specify the text splitter. In my case, I said semantic splitter, but this is really required. This is just like an option for our chunking, how to create these chunks for our VectorDB. There are different strategies, and this is just like a more smarter way to do it against doing it just like dividing it by 1,000 tokens, characters, sorry. And that's it. Let's open our Docker file Flask. in this time, we see that everything is build process is happening, so we are not wasting time. What's happening here in our Rack application? We're using Python 3.9. We are taking our install and upgrading pip, Python installing all the requirements for us. This is just like Langchain, Python dev, Flask, OpenAI, transformers, sentence transformers, face, our vector DB, and text generation, of course, because we want to use it to communicate with open source Llama. We're installing it here, exposing the port, taking the text splitter from the, if it's not set up, it's going to be character splitter, but I specify in arguments in Docker Compose in the higher level abstraction that we are going to use semantic splitter, so it's overridden here. And probably that's it. At the end, we just copy the whole application files inside our Docker image, and Docker run is going to run our application as an endpoint with Python 3, SRC, Flask, Rack, LLM, OpenAI, HuggingFace.py file. So this is our endpoint to start our application. Okay, fine, cool. What we have to do next is just, while we're still waiting, let's dive into our application and how it works. You're seeing our SRC. This is our sources, stands for sources. You're seeing our main file, which is our main endpoint, and you're seeing also templates, HTML templates, and our custom chat history. Okay, let's start from the HuggingFace templates. What you're seeing is just our front end parts. This is going to be responsible for our front end. It's completely the same. The difference will be provided only in one place. What we're seeing is just we're importing our jQuery. We're going to use this one, specifying just a lot of styles which we want to use, specifying our chat container. I'm going to show how it looks like. Probably, let's be in Chrome. This is just like an application for us. We can use send. It's not working because it's not connected with backend, but we can write something and send it to backend. And afterwards, when it will be connected, we'll be provided with a response. Okay, I close it. This is our chat container, and our main function, which is a script function, get bot response. What we have in here, this is the whole, the starting point for us. The main function, we are taking the raw text, right, from our chat container. We're taking the specifying in hard-coded way that index of this HTML file. In our case, this is HuggingFace. In OpenAI, this is OpenAI. In OpenAI, this is the only one difference. Afterwards, they both have generate method for API, where we are just sending the message, which is our raw text and index, to our backend, and getting response back from the backend and providing it back. And it's run when we are clicking on enter or sending our get bot response button. So that's it. I close it. Then I'm opening Flask, Rack, LLM, OpenAI, and want to show to look into what is going on in here. So we're still building something. We're still in our Rack application. So waiting. I'll just, it's better this way. Click, 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 click. Okay, let's start explaining what is going on here. We're going to explore this script from the top to the bottom. Import. Imports, nothing to say here. We're just doing importing. Then we are loading our .env file. .env file in our case consists our OpenAI API key. It will be required to compare our models and initialize our Flask application. Okay, we having for our backend, Flask is going to be responsible for our backend. So in our backend, we have two home pages for OpenAI and HuggingFace. For OpenAI and HuggingFace, we have our HTMLs, right, which we saw before, with our charts. And we have the generate, which is similar for both LLMs. We're taking this data and user tags, we're taking the data which consists user tags and index from our front end. Then we have our, we understand which, by index, we understand which model we want to use. If we want to use HuggingFace, we're diving into this object, HuggingFace LLM, otherwise in OpenAI LLM, and running the generate for us, providing the text. And that's it. If the error, this is the error, and we response which we get, we send back to our front end. In terms of main script, when it started, we are going in here, and we are getting the text splitter from our Docker Compose. It's going to be overridden by semantic splitter. Then we initialize our OpenAI RAG LLM and HuggingFace RAG LLM. I divided this init logic into two parts. In init, we have just, in Python init, we have just simple initialization. In initialize part is responsible for complex initialization. For example, like loading the weight. It's just a great, good practice to modularize your code if you have different complexity of initializations inside. Okay, and we are running our Flask application. Cool. Let's look into our OpenAI RAG LLM. What you are seeing, this is our 3 classes. That's it. This one is just a mixing class. This one is responsible for having the general and similar for both LLMs logic, and we inherit this RAG logic for both LLMs. So you're seeing in here and in here, we inherit the whole functionality which was written to RAG. This is done to not copy the same code 2 times. Okay, OpenAI RAG LLM, how does it look? We are specifying LLM we want to use. In our case, we're working with GPT 3.5 Turbo, going inside through Connect to this model. How we're doing it? We're doing it through Langchain OpenAI chat OpenAI class, which provides us the object of LLM, which we can interact with Langchain afterwards. We're specifying the custom chat history. The custom chat history, we're specifying the prefixes we want to use. It differs from model to model. In OpenAI, we're using human to and AI prefixes. In HuggingFace, we're using different inst and inst with closed hash / inst prefixes. So it's a little bit different. You have to understand it. Prompt template, going inside, diving into. You are helpful, respectful, and honest assistant. You help to answer questions regarding attention. Is all you need article. Answer the following question based on the context only. Only answer from the context. If you don't know the answer, say, I don't know. This is very important part. It helps us to distinguish the reasoning capacity of different models and compare them. Because anyway, all of the models provide you some response, a response in text, and you may not understand whether this is good or bad, right? But if you specify just answer only based on the context and the model answer is it anyway, then probably we need to change this model. We will talk a little bit about this later. We specify in the chat history, content, the question. This will be filled with, these gaps will be filled with, with textual information afterwards when the prompt is going to be used for invoking allow. Generate. We're having search results. It's similar it's taken from our mixing RAG class. It's similar for both of the classes. It's responsible for taking the input, going into VectorDB, looking into similar embeddings, taking based on these embeddings, textual chunks, and combining these textual chunks together. Afterwards, we're taking the prompt and putting this content, like content combined in here, because from here we can take, for example, three top context chunks and combine them together. So we're putting it here. Chat history goes here, and question goes as a from input. Then we're invoking our LLM with this prompt, update our history, and return the response back to our front end. The same completely logic happening with HuggingFace. HuggingFace, we have the same, almost the same prompt, except the format of the answer is final answer. Put your answer here. It's very important because Llama by itself often tries to put some information, I cannot say random information, but information before and after the response. So he can provide, for example, like some smile at the beginning, and we don't need this smile. We want this just explicitly the response for this to this question, and not just smile at the beginning, right? This is why I'm putting this the logic for answering with some specific format, and afterwards I'm just taking this format and parse this format as in post-processing step. So this is just a little bit difference with custom chat I explained and connect to the model. It's a little bit different because in OpenAI we're connecting to through API, right, provided to us in paying money just for our queries. But for in our case, what we're doing, we're just specifying the URL. This is our open source LLM, which we already set up, and it's already done and ready for us. We can use this LLM service because like this way to communicate with LLM, because we are using the same network in our Docker Compose. It returns us the object object of LLM, which we can use for communication. Probably that's it. This is done. Generate is completely the same except this post-processing final answer. So it's completely the same as in OpenAI part. I close this one, open the RAG generator mixin. What we have in here, we're having our init part, right? We're initializing LLM, chat history, VectorDB embeddings model, and text splitter. Initialize for complicated initialization. We're loading our embeddings model and the VectorDB initializing VectorDB and filling it with our with our textual data chunks, right? Initialize our embedding model. This is our HuggingFace embeddings, which we are using all mini LM L12 V2. Don't forget using normalized embeddings, because you will not be able to compare it if it will be not normalized, so be careful with it. It's not a joke. What's next? We're initializing our VectorDB. In my case, it's face. We're taking the get chunks method. Just a second. Get chunks. We're get chunks. In get chunks, we're taking our attention is all you need article, loading it into our PDF, right? Afterwards, we are specifying what strategy we want to use for our splitting. In semantic way, it's more like we are taking the embeddings, and by embeddings we understand which the strategy, for example, like strategy of chunks. We understand that this has to be together and this one has to be, out of this scope. And in here we just taking 1,000 chunk size characters and just nothing more, nothing less. So it's more like a way to explore the different semantics, different splitters to get the higher and better response capabilities. Okay, we're loading our chunks back. And this is, in our case, this is our documents where we are loading into our face DB. And what we already have, we have our VectorDB. It's with information. It's loaded with our data chunks and embeddings. What we're doing is just going in, running similarity search against it. We're providing our input and number of chunks we want to get back. We're getting back our content, right? We initialize it as empty string, and afterwards start to concatenate it. We iterate and concatenate with page content which were provided for us from our search results. So probably that's it. And afterwards, we provide this content combined back to our OpenAI and HuggingFace models in here, like search results, right? Probably, yeah. It's honestly very simple in how it works. There is no fine tuning part and some other stuff. So what I want to mention also is custom chat history. In custom chat history, we have simple custom DAC. In my case, this is just a DAC data structure. And custom chat buffer history consists of this custom DAC. We have different prefixes, right? We're specifying prefixes we want to put our entries. Our entries consist of human query and AI response. We take these, we take human query, AI response, put it into entry regarding all these prefixes, and just update our entry. Update our memory using this entry. If the length is more than k, we just hop left it, and that's it. Let's look into our application. Right, it's running. We want to run against it. Just here. This is 5000 port. OpenAI. Yeah, everything is okay, and I'm doing the same for HuggingFace. HuggingFace, cool. Right now, what we have to do is just try different queries against it in here. In HuggingFace, my name is Ivan, goes in here and in here. What did I say? And what is the capital of France? Awesome, right? Awesome. What do you see? Explain transformers as in the article, right? You see there how it looks, and the response provided to you looks a little bit different from what you get used to seeing in ChatGPT. But it's because we're using the context of our attention is all we need article, and you see that it's right. It's a little bit different. Then we are starting to ask, what is my name? What did I say? I know, what is the capital of France? And you're seeing the you getting the response, I don't know. And this is correct response, but because this is not, Ivan is not related to the context, what was provided to us, right? Which is related to attention is all we need article. What's about HuggingFace? You've seen that this is a lot of everything. Just he took everything from the context and put it here. My name is Ivan. Not related to the answer text. He stops misleading and seeing the information from the context, from chat history and some other stuff. So from this model, he needs a little bit more reasoning. What did I say? Again, he tries to explain something. And what is the capital of France? I don't know. And he provides a lot of text afterwards. So it's kind of like it could be improved. Like what I want to stress, that it doesn't mean that HuggingFace Llama 2.13b is bad and OpenAI GPT 3.5 is super good, right? The idea is that probably the model which we used, and we use quantized model with shortened weights, right? We haven't used the initial 16 bits LLM Llama 2.13b. We used 4 bits GPT quantized LLM. Which has less, reasoning. And if you want to make sure that Llama 2 is worse in your scenario, you need to try probably, full model, or even if it doesn't help you, you can try even bigger models, right? Like Llama 70B, Mistral, Zephyr, and some other LLMs. Probably, I believe that's it from my side. Honestly, the only one thing that what we have to do is just delete what we created, because it's what good people do. They delete after yourself. In a minute, everything will be deleted and all of the resources will be deleted and not, and even you already cannot communicate with our LLM and it's closed. So thank you very much for this, for watching, and I provide my word to Lucian back.
Amazing. Thank you very much. Very intense and very insightful, Ivan. Would you please allow me to share the screen back?
Yeah, sure. Stop from my side.
Okay, I think it takes like a few seconds. Okay, so again, thank you very much for so many insights. I think now everyone everyone saw that we started this LLM wrapper with Java. We moved to Python just because we want to showcase more languages, but this doesn't mean Python or Java is better than the other. So this is not the scope of, we are not analyzing, we are not comparing the quality of the power of large language models or the programming languages here. We are just trying to showcase the capabilities of C-Clumps and our team to work with different technology stack. Of course, Python in this regard has a bit like probably bigger community, more support for different LLMs or for different libraries. But again, it's not in the scope of today's session. We just reviewed how to build this in detail with Python. So it was a POC, but you saw it's a working POC, and it's more than an LLM wrapper. You can do so many things in like a very short amount of time. Ivan demonstrated how to build a Docker image, how to move it to deploy it to AWS, and how to leverage FAIS database in order to retrieve the result, the semantic result, semantic similarity for our queries, for our prompt. And now, let me quickly, before moving forward, let me quickly introduce you some fundamentals about data chunking, because you constantly hear data chunking, right? It's fixed data chunking, it's semantic data chunking. So what is it? What is this data chunking, and why do we need it in order to build RAGs and in order to interact with LLMs? So you probably also hear everywhere that large language models have a limited capacity for the context. So they cannot, like, it is exactly like human mind works, right? You cannot digest unlimited information with unlimited context, right? You need to contextualize the discussion or the application or the discussion or the topic that you are analyzing, right? And also, when we are discussing with a large language model, we have like limited context that we can send to it, right? We cannot use too much information to pass to the LLM when we use this approach of building prompt and empowering the prompt, right? You cannot, and probably you don't even want, because you are an enterprise system, you have a lot of proprietary data. You don't want to share that within the structure, the core of the neural network of large language model, right? So this is why you need to keep it externally somewhere into a different database, and you need to divide your data in smaller chunks that make sense, that they make sense together. Because when we do data chunking, we can either do it based on fixed size. So we can, let's say you have a document, a 10 pages document, right? You can create data chunks by taking page by page the document and index it in your database, and then search there which page is the most relevant for you. But you can also do a more advanced, as Ivan mentioned, you can do a semantic chunking, and that means you split that document, that 10 pages document, you split it in a way that it makes sense, right? So you are stopping the split there where you are switching the context within that that document, and this is providing you more power to search the document and then to enrich the context that we are adding to the prompt. So when we are discussing with a large language model, then you are adding that relevant context, and the LLM will basically answer in context, right? And the data is still yours, it's still private, and it's still isolated there. You can remove it anytime you want, right? So this is the benefit of using data chunk, and this is why we need to do that. And there are a lot of techniques to do this. We will send more information about that in some references in a follow-up email after this session. Further on, we need to demonstrate another use case with another programming language. And for that, I'm inviting my colleague, Daniel Gorgan, who is a senior JavaScript developer. He will demonstrate how to do the same thing, but with TypeScript, and how to change the approach, not using Face, but using a database that it's probably more familiar to you. It's Postgres. Hello, Daniel, and
hello. Thank you. Nicely said. So I will share my.
Let me stop sharing the screen.
All right. So JavaScript couldn't miss the fun in being part of this. Of course, there are some other notable libraries. Can you hear me?
Yeah, I just said sure. Okay. Go ahead. Sorry.
So yeah, the exception I was talking about is basically TensorFlow for JS. But today we have another concrete example, which would be Langchain JS. And we will combine it with, of course, as Lucian mentioned, with the PG vector store. And without further ado, let's see why and how they both work so well together. So starting from the documentation page of the Langchain, you can actually directly spot in that the Langchain is actually written in TypeScript. So don't worry, or the TypeScript developers out there, don't worry. Got you covered regarding the types. And also, my demo will also be in TypeScript. So make sure before actually using Langchain to check the documentation page to see how can you configure it based on your environment. In my case, I'll be using Node.js. So let's jump into the code. So these are pretty much all the Langchain dependencies that you would need. And of course, as you can already tell, you have to use it in order to expose it to a client. As Ivan did in the previous example, I'm also using the same interface. I'm exposing it using a server-side API, and namely Nest.js, but of course you can use your most preferred one, for example, Express.js, which is highly popular. So in my case, I prepared two services in a Docker Compose file. One would be the Node.js application file, which is actually doing nothing else, or is more like a regular Docker file for a Node.js application that you usually run for production. So you can note that there are actually no prerequisites needed for building the Langchain, since it's yet another Node.js package. And of course, I'm using the OpenAI cloud, so I don't need to set up anything locally regarding the model. And the other thing more important for this part would be the vector DB, which right now we are creating our persistence layer, making it therefore independent of the application state, of course, making it reusable across different applications. And in my case, I choose the PG vectors store, which PG stands for Postgres. So first of all, it's great news that, Postgres, as you might already know, it's one of the tech giants when it comes to SQL databases. So they actually just released the support for the vector store. So these are great news for people working towards this domain. And secondly, behind the scenes, the vector store is nothing else but a Postgres extension. So you can use your already known knowledge regarding the Postgres. You can already easily integrate it and reuse basically the code, or reuse the Postgres implementations. You can see it behind the scenes like yet another table. Cool. Let's go into the extra logic. All right. So we have the OpenAI module, which was implemented. Everything else is just some Nest.js specific modules using for static files or configuration. All right. So with our API, we're exposing a single method, which would be our generate method. And the controller is doing nothing else but delegating the task to the service, which the service is going to be the layer which is actually containing all of our business logic. And as also Lucian mentioned before, and let me mention it again, it's actually implementing the same logic as in the Python code. So basically, as long as you know your principles regarding the building a RAG chatbot, or knowing that the Langchain framework per se, everything else is rather but a preference. So before actually jumping into the logic, let's quickly have a look on the vector DB module. So for you people out there that are working with Node.js, TypeScript, and usually Nest.js coming hand in hand with the type ORM, They actually provide support for you can see that I imported my type ORM from Langchain. So it got support for the vector store, which is great news. So I'm just doing exactly that. I'm using it to initialize my VectorDB instance. For that, I'm using the OpenAI embeddings. And I'm also initializing it the same manner as Ivan did, but in my case, I'm just using a simple character text splitter, but everything else remained the same. I'm using PDF loader also from Langchain, getting the same file, and then splitting it into chunks, which I'm then initializing it. I'm using the chunks and adding them into the database. Anything else is just some quick logic that just to show that you can actually reuse some of the current implementation. In my case, I'm just using the regular PG client in order to check that if my table was already populated, so I don't have to reinitialize it again. All right, of course, this is one way to do it. Let's go back to our service. I'm also using a prompt, the same prompt as before. So just a quick recap. We are asking questions regarding the Teshaolin article. We're also providing a chat history. We're providing some context, which will be actually the data we're going to retrieve from our vector store, and of course, our question. As for the chat history, it's implementing exactly the same custom in-memory chat history, but of course, just as an example, Langchain actually provides different memory types. So make sure to check the documentation and find maybe already one that is implemented that is actually suiting your use case. All right, so we're initializing our OpenAI client. We are also importing it from the Langchain/OpenAI, and I'm using GPT 3.5 Turbo. Cool. So going to our generate method, it's again doing pretty much the same thing, but this time actually we are using the similarity search, but with PG vector this time. We are getting then the response, we're combining them, and then we are creating our prompt where we're passing basically the context, and then we are calling our model. All right, let's actually see it in practice. Let's interact with the bot. Let's ask him a question. What are transformers? Right, so we are getting a transformer definition, which is actually based on the article. So basically, it's a more precise definition based on the article. You can't really tell right now, but I can show you the logs that were actually successfully retrieved the vectors or the relevant vectors from a vector store, and then we are basically passing it to our prompt in the context, and therefore the model will ask or respond accordingly. All right, so just to show that this is indeed happening, let's combine the similarity search result in order to not actually send anything from our vector store. We are also, since we're not going to use the chat history, since it was in memory, so now the application restart, so it won't interfere with the previous answer. All right, so now we can see, or again, maybe it's not really that obvious, but now there will be a more general response just because we are not passing anything in the way of a context for the bot to actually answer. So as previously showed as example. So one more thing that we could be doing to actually make the bot to respond even more different. Let's increase the temperature, and of course, increasing the temperature should make somewhat the response, let's say, more creative. But be careful when tweaking all of these options because for example, increasing the temperature could also make the bot respond slower. All right, so now we can actually see a third variation of the answer now because we have the temperature, but of course, in order to fine tune it, make sure to check all the available options that you can configure your model to. So make sure to play along, configure it, and create the right chatbot that will basically suit your needs. And so yeah, that would be one example of how you could create a RAG chatbot using TypeScript or JavaScript, and that's just everything combined. So thank you, Lucian.
Very nice. Thank you, Daniel. Let's continue with some details, some concept, some explanation about some concepts that you also mentioned, and Ivan. So let me please recap what we did here with Daniel. It's basically we did exactly the same thing as we did initially in Python, but now we use the power of Postgres so we leverage Postgres to execute this semantic search. And you probably also hear you heard during the session a lot of times that we are using embeddings, models, and vector databases. So let's quickly see how are these databases working, how these embeddings and the technology working, and what is similarity in the sense of a retrieval augmented generation system. So basically, embeddings are numerical representations of concepts, right? So, in traditional software development, we basically have all of our data represented numerically, of course, binary in 0 and 1, but they do not necessarily have a sense. They don't have a meaning, right? And when we look to the data generally, and when we look to the entities, we usually compare them, especially on words, because we are discussing about natural language here. So when we are looking to the words, we are checking if they are alike in appearance, right? But what we want to do more in order to find the context for our query in the database, we want to do this similarity search. And how we do that? We do it by performing a semantic search, right? This semantic search it tells us how are these entities alike in meaning, not in how they look like, right? And let me give you an example. Maybe this will help you understand easier what this similarity is and how is it working in the realm of machines, right? So let's take an example of 3 words. We have mountain, we have river, and we have canal, right? So we can do a numerical representation for them, and this is something like this. It's one hot encoding call, and it's basically we're assigning to each word a number, right? We have a numerical representation now, but does it tell anything about the relation between the words? No. So the relation between the concepts, what is a mountain? Is it closer in meaning that to river than the canal or the reverse? We don't know, right? But what we can do is to add some more dimensions. So we can expand this numerical representation by adding more and more dimensions. And of course, it's hard for human eye and human brain to perceive like hundreds or thousands of dimensions, but we can do this bidimensionally, and it will look very, very nice for you and easy to understand. So let's add to these concepts 2-dimensional space to consider them in 2-dimensional space. So basically, we will consider if they are natural or artificial, and if they are mobile or static, right? So we have mountain, we have river, and we have canal. And we take the interval between -1 and 1, right? -1, it means more natural, while on the second dimension, -1 means static, right? Closer to 1, it's more mobile, right? And now let's try to represent this on a graphic, on a plane like this. And here we have canal, we have river, and we have mountain. And here you can easily see with your free eye which is more similar to the other. This is how machine thinks, and this is how they compare the concepts. This is how they compare a river with a canal and with a mountain, and they say river is closer to the canal in a meaning, right? It's just they do not do this in only 2 dimensions. They usually do this in hundreds or even more dimensions, right? And the techniques is on the techniques that I'm using here to explain this this concept is cosine similarity, but there are more more options to do this similarity search, right? So further, we will basically change again the approach how we search through the vector database by replacing FAIS that was initially used by Ivan. Later we used Postgres, and now my colleague Saikumar Uko, who is a conversational AI expert, he will be using Quadrant, and he will explain how to leverage Quadrant in order to get relevant answers and to enrich your context, and how you can deploy your Python application. We are taking the same example of Python application, how you can deploy it in Azure, right? Can we do that, Saikumar? Let's see.
Sure.
Hello.
Thanks, Lucian.
You can take the
Great.
screen.
Great. Let me start sharing my screen. Just let me know if my screen is up.
Yes, it's
Right.
visible. Yeah.
Okay, perfect. All right. So let's start looking at the code itself, right? So earlier we went through this whole script while we were discussing with Ivan, and we tried to look at how we were trying to create the embeddings, where we were storing them on a FAIS vector database. But now we'll try and use Quadrant open source vector DB as one of the service, and we will use that as our vector store. And the reason behind doing that is because, again, Quadrant has much more flexibility in terms of CRUD operations that you would do, and you can maintain your data a bit more efficiently, right? So for that purpose, we are now again importing Quadrant package here, and then similarly we will need the Quadrant client in order to insert the data and also retrieve the data back from it. So if we go back to the stage where we were initializing our vector database, we will be doing something similar as we did for FAIS, but now we will actually be, inserting the data into a Quadrant DB. So this is that API change that we have compared to your FAIS way of inserting them. And at the same time, I have these two differently here, just in case if you want to run it in memory and you don't want to have a service externally that is, running your Quadrant database server, or, you can always have your Quadrant database as a separate service on a Kubernetes, and you can still keep using that, right? And then at the same time, I also slightly tweaked the chat history part of it. So earlier we were trying to use the in-memory way of having the conversations inside the memory itself. But additionally here, I've also included the Redis server, which will keep on, accumulating the conversation which the user has just had with the bot. And, we'll keep on stacking them against a certain user session, right? So for the sake of simplicity, I've just used user one as a session ID, but you can again keep changing that based on who the user is and the way he has logged in onto your browser, and maybe you have a specific token or an ID that you can tie up the whole conversation with, right? So for the sake of simplicity, we have just taken user one as the session ID, and we keep using that for updating and retrieving the data from the Redis. All right, and little more because we are using Redis so efficiently, we also are going to use the Redis package, similarly the Quadrant. And because we actually saw OpenLLM implementation from Ivan, it'll probably be the same if you do it on a Azure VM, but for the sake of time, we'll only be publishing the OpenAI version of this, bot, and we'll try to see how we can, leverage the power of Quadrant DB and Redis in between. All right. So those were the changes, and similarly, we also have the environment file updated because these are the respective endpoints that have to be accessed by the Flask program in order to connect to these services. Okay. All right. So now that we have looked into the changes that happened, we will try to just look at what else we have to cover. So we looked at the Okay, so there was also a change that had to be done to the Docker file because we totally removed out the open source LLM, and we just want to run the OpenAI through the API call. So that's much smaller Docker file right now, and this is the only Flask API program that will be actually running once we deploy it. Okay. So this being the Docker file, we will actually go ahead and build the Docker image on my local system itself, and then try to publish that to a Docker registry on Azure. And from there, you can always keep consuming it anywhere on your Azure infrastructure and other services. So let's get started on how we can actually do it. So right now, I actually am on my same folder as the LLM Flask RAG Azure. And I have also activated my environment for my Python. So first thing first, I'll go ahead and install my dependencies. So let's go ahead and do that. Pip install requirements. So it will probably take a while if you are doing it for the first time, but I already had all these installed. So if not the case, it'll take a couple of minutes, but yeah, right now we are good and ready, right? And then we also need to get our Docker container service up and running, because I wouldn't want to use the in-memory, but I want to have Docker, I want to have the Quadrant database as a separate service altogether, right? So if you look at my Docker here, you'll actually see they're paused right now. They're not running at the moment. So I'll go ahead and run both the Docker and the Redis containers, and you should see them running on my, the Docker UI. So that should be good for the Quadrant database, and now for the Redis as well. So there you go. So you have your Quadrant DB running, and probably just remove the other ones so that I can just start my Redis server again. And there you go. Let me try it again, and it should be good. Okay. So go back and look at your Docker, and you see both of them are running. So if you even go and access this particular local host, you should be able to see that message saying, hey, vector search engine is running. Okay. So that part is good. Now, what we'll do next is we'll keep running the same Flask program, and then try to interact with the bot. And you're now interacting on your local machine with the Quadrant and also the Redis on your same PC, right? So let's get into the source folder. Then it should be src. There you go. Okay, then we start our Flask server. And once you do that, you should be able to go access that similar UI we were trying to access earlier, right? So what it's doing right now, it's just trying to create those chunking, create those embeddings, and then also inserting that back into the Quadrant database. So it takes those few seconds in order to initialize. And once that's ready, so there you go. So you have your endpoint, and I can go access it, but you're not able to see anything here because we were supposed to get into OpenAI as the endpoint in order to access the bot. And there you go. So you are able to see the actual bot right now. Yeah. And let's go interact with it. So I'll try something different as a question. So what is this document about, right? So that is a question, and we got a good enough answer saying, hey, this is about the transformer architecture, etc. And just for the sake of reference, so this is that PDF which we have been using throughout the demo. Attention is all you need. And it does mention something relevant to the document. All right. And just to try something related to the chat history. So let me ask a question like, what did the human ask, right? So this is something that's totally out of your, LLM, and it's specifically related to your context. So let me input that. So maybe it is not picking up right now. So let me try to rephrase it. What was the first question? So let's just look at the context history. So it's probably not picking up the history. So let me try to just restart my Flask server because maybe it has not been able to pick up the latest Redis. So let's try it again. Well, again, let's give it a couple of seconds and, it should be back up to the same stage. It's completing the text splitting and, in a moment, we should be back up. Okay, let's try it again. Refresh it. What is the doc about? What was the first question from the human? So it looks like we are unable to look at the data, but at least, here we do see what the human just asked. So let's try it in a bit more straightforward fashion. What was the message from a human? Okay, there you go. So, you're just trying to fine tune the way of how you're asking your question. So it's again in the realms of prompt engineering. So this is how you're actually able to retrieve some data back from the context history. Not always you would have a user who is trying to get data out of his chat history, but the whole reason to actually show this, when you have a application which is built for real-time use, you will actually need some context history which is there in the background in order to orchestrate your chat itself. So that is the main reason for having this chat history and trying to reuse that here. So with that being said, we were able to do this quick demo on my local machine, and what we'll do right now is we'll try to build that as an image on my local machine and then try to publish it to Azure. So what I'll quickly do here is I'll just stop my Flask server and then try to build my, image. So there you go. I'm trying to hit Control Z to stop that. It's Python doing Python and Flask stuff. So whenever we want to stop it, it takes a while. So let's give it a couple of seconds. Okay. In the meantime, what I'll actually do is I'll just maybe start a different, shell altogether, and maybe we'll get started from there. CD into LLM Azure, and we also need to activate our environment. Okay, we have done activating. We are moving back to a folder. I'm just checking if we are, into that particular folder which has Docker file. So yes, we do have it. And a few different commands that you will see here is, we actually want to push the image to our, registry, which is on Azure. So, for that purpose, you actually need to log into your Azure subscription. So if I have already logged into Azure, I'll not have to do it, again, and it will not be interactive. But if it's already logged in and if the session is still valid, so we'll get through pretty quick through these 3 steps. All right. So AZ login is again a Azure CLI command that lets you log in. So, I'm trying to log into my machine, and once you're here, you should be able to get that response saying, hey, you are logged in, and it'll actually show you the list of subscriptions you are assigned. There you go. And I am actually selecting this specific subscription because that's where we would like to deploy this whole demo. And we are into that subscription, and this is the login for the registry itself. So we are logging into that as well. And this will actually provide the access for us to now push the image, right? So it's taking a couple of seconds. Let's wait for that. There you go. Okay. So we have the login succeeded. Now we'll actually go ahead and build this whole image, and it generally might take 100 to 200 seconds, depending on my network bandwidth and the other aspects. But there you go. So the build has started, and what we'll do after that is, once the image has been built, we'll actually push that into the registry on Azure, right? So while that's happening, what we'll actually look at is where we are going to deploy this whole instance, right? So earlier we used, EC2 instance on AWS, but here we'll actually try to use the serverless way of deploying your app, whether it's your plain Flask application or you want an application that's, hosting your, let's say a custom LLM or your open source LLM, you can still do it this way, but, the price for GPU is pretty high on container app as a service. So that's one reason, and also for the reason of time, we are going to do just the Python Flask with the OpenAI. But back to the topic again of how the container app works on Azure is we just use the image that's on registry, and we are able to deploy that single image as a service on a container each. And then we are able to, consume that endpoint as a website or a additional API if you want to use it anywhere, right? So this particular page is, now going to show you the resource group, which actually has the container apps environment, and it also has the set of container apps which we have tried to deploy onto this container environment. So we'll not be doing this container app publishing or deployment here, but we already have it right now. But you can still do it on your subscription. It takes a couple of minutes. So for the sake of time, we already have the environment. But we'll actually look at how we can deploy a new container app into this container apps environment. Yep. And I'm going to just check back if we are done building. Okay, there you go. We are done with 75 seconds. There's a build time. We'll try to push this into the Azure container registry. There you go. Okay, so it's going to do its job, and I'll just head back to the Azure portal. So if you look at the container apps environment, this is how it is configured right now. It's probably the smallest tire that you could find on a container apps environment because it's a consumption plan. And at the same time, you still are able to use the GPU, but you are supposed to pay per hour basis. But the one which we are using right now, it's more on the per usage basis, where you probably are charged this much, 0.00034 USD per second of CPU usage, and similarly for your RAM usage, right? And there is also a charge for your idle time that your container app is active. So you can publish it that way, or which is actually the consumption way of publishing it, or you could also use a dedicated plan where you're charged every second, even if you're not using the resource. So we'll not go this route, and we are actually going through this route here. All right, let's look at the push. Okay, it's still a few more seconds away. And let's look at the container apps environment. Yeah. And just trying to show you the container apps which are actually under it. And if you see, these are the three container apps which we tried to deploy earlier this week. And we will actually try to go ahead and deploy a fresh new container app. And before we do that, I want to get this, image pushed to the registry, and we can go ahead and use that. So while that's happening, I would like to show you something special here. So if you get into this, you only see 3 container apps, but when you look at it here, you actually see the number to be 5. That's because there are 2 other services, or the container apps, which is your Quadrant DB and your Redis server. So these have been deployed as a sidecar rather than a separate entity or a separate container app altogether. just to show that you can still use Sidecar as a feature on this particular service, but in your production, maybe you want to have those as a separate service, and then maybe you want to consume them at the end of the day, right? So when we are actually building the container app, we'll also try to push in or try to attach these add-ons while we are deploying the image. And at the same time, we also have to key in the environment variables, which we had them here on the file. Okay, there you go. So we have been able to push the image. Now, it's probably just a few seconds away where we can go ahead and create a new app with the image that we have just built, right? And the whole aspect is to just show the reusability, where we had a whole Kubernetes cluster spinned out of EC2, and we had a similar image built there, and we also had a similar Docker file format. But come here into a serverless, we can still use those same files, and it still gives you much more flexibility in terms of deploying and trying to split your services and have them individually on a different app altogether. Okay, so let's go ahead and create the app. All right. We are going to create the app using the option there, and we are going to use the same resource group, and I'm going to try and name it seeing PDF3. So this is a unique name which I haven't used before. And this is the same container apps environment which we just saw prior to this. And next, let's look at the container. So this is where you actually have to select your registry. This is the registry where we just pushed our image to. We're going to select OpenAI. That's the image. And the tag was the latest that we have actually used, right? We don't have any command overrides to be done, so we'll leave it as it is. We'll probably, this is our workload profile, and this is the particular combination which works fine, 0.5 CPU and 1 gigabit, because we don't have much happening on this small little app. Okay, now let's key in our environment variables. It's going to be as straightforward as this. So OpenAI, and I'm going to copy the keys, and I'll also try to create Redis password. So you wouldn't need to do these things because the sidecar already takes care of that. So just the OpenAI key, that should be sufficient. Next is the bindings. So this is where we are actually going to add those 2 bindings we had earlier. So this actually provides you a way to create a new binding, but you already have something handy, so why not use them? So one is your quadrant DB, you connect it. Similarly, you have another binding for your Redis, which is already done. You connect it, and there you go. So you can now start accessing these 2 services from your container app, and even the the environment variables are directly exposed. Okay. Then next into ingress, and I want to enable ingress because I have to access it, and I also want to access this from anywhere because that's the endpoint. And I also am going to provide the port number, which is the 5000, if you remember, for your Flask application, right? I don't want any tags, but we can just move forward, and it's just going to validate in a couple of seconds, and we can go ahead and create this. There you go. So again, it takes a couple of seconds because it has to go pull that image and deploy it. And in the meantime, I'll just go back and show you the quadrant, app that we had there. And what we'll actually do here is we'll do a scenario of failover where, your quadrant DB is probably down, and, your bot would stop working. But again, when your DB is again back up, you'll still be able to talk to your bot. And the good thing is, the embeddings that you created before, they should still be intact, because earlier when you're using files or any other in memory, you will again have to start your server in order to load the data back. But because there is a persistent layer behind your quadrant database, you wouldn't need to redo that whole thing. So it's just going to take a couple of seconds, and we should be able to see this service back up. In the meanwhile, I'll also try to bring up my Redis server on a different page, a different tab. But let's look back at the deployment that's in progress. Okay. So right now it's trying to build the bindings for that particular app. So it's going to take a couple of more seconds for the Redis binding to be done. And once it's there, we should be able to go directly access that URL, right? So you could also see how this particular container is built. And if you look at the bindings, you should be able to see that it doesn't have any bindings, because bindings only apply to your main container. And similarly, you don't have any environment variables, because this is just an out-of-the-box quadrant database. Okay, there you go. The deployment is complete, and now we can start looking at the app that's here. And if you look at it under the revisions and replica tab, you can actually see what the status of it is. So as you see, it took a while. Maybe it failed earlier, but right now it's trying to process again. So hopefully it should be up quite soon. Yeah. So let's see if we can refresh it and something changes, because it generally takes a couple of seconds to spin back a new replica altogether. And at the same time, one another nifty feature that the container app has is, if when you're shifting from one version to another version of your app, you can actually have multiple such replicas active, and you can again distribute your traffic accordingly. And that actually is again quite flexible, of just doing a few clicks, and you're able to do a release a bit more smoothly, and you have a lot of control on that. Let's see if we can have it running. Okay, there you go. All right. Moment of truth. So there you go. We have a similar error. Now let's go into the endpoint of OpenAI. There you go. So we have the same app which we were able to run on your local machine, and we are here in like about 10 minutes. And you also have a Docker image build, which you can again keep reusing wherever you want, right? So let me ask those similar set of questions. What is this doc about, right? And we are expecting a same answer or a similar one, which is good. And maybe ask that question of the chat history as well. So what was the first question? Let's see if we can actually try and see what was the question from the human. The question from the human was, what is the first question from the human? So, it's trying to pick the context just from my previous message rather than from my first question. But, at least to get an idea that it's in fact picking from the context. And again, it's up to your prompt engineering to fine tune it and then maybe improve the user experience, right? So one final thing, like I promised, we'll do a failover and we'll see how it actually works in real time. So what I'm going to do is I'm just going to stop my quadrant database service. And what that means is I shouldn't be able to retrieve anything through the RAG process, and I shouldn't be getting any valid response. So let me ask the same question. What is this doc about, right?
So we are falling back to a LLM wrapper, basically.
Right. So like we said, so we are actually trying to see, hey, we don't have a quadrant DB running in the background. So if you want to just show an outage message, but like Lucian mentioned, it could be this way of doing it, or, a fallback could be, just a pure LLM way where you're not retrieving anything from your RAG, but, straightforward from your LLM. But again, you can to either of them, which is more comfortable and relevant to your industry. Now, let me start it back up. And again, I don't have to create those embeddings again and go insert in my database or do anything of that sort, but they are supposed to be there on this database once it's up. And the service is up. I'll try to put that same question. What is this talk about, right? And we should be able to get a response that's coming out of the whole RAG flow. So just to summarize, this is one additional feature over and above what we started initially, where we are adding a layer of context, we are adding a layer of chat history, we are trying to do something personalized based on a session. So this is probably just getting started, and when you want to do it at a production level, you will have to fine tune it much more. And once you are there, probably you should have a quite a good, robust solution to work with, and also, the testing that has to be done, and something that we'll keep talking about. But that's what I wanted to really show. And thank you. Over to you, Shyam.
Thank you very much, Sai Kumar. So thanks everyone for staying with us. We finished the practical presentation. I think we just started one, and 20 minutes ago or anyway 80 minutes ago, let's say. And I think you saw so many things in this time. We started from building a LLM wrapper with Java. Further on, we went further, rewrote the application with Python. Even further, we deployed the application in either locally on AWS, on Azure. You saw all the steps you need to do in order to do that. And you already saw 3 alternatives of vector databases, and on top of using Python and Java, which are quite popular in AI world, we also use JavaScript as an alternative. So basically, I think in only 80 minutes, you saw that we have so many alternatives and so many possibilities to do these things. Or if you do not want to do that, we can do that definitely, because as you saw, our team of specialists is it's so experienced, so we can tackle any potential use case that you can, or technology stack that you can think of. So I think what's more important than that, it's not only that we highlighted all of these possibilities, all of these options, but we also highlighted that here we are working together as one team. It's not only individual experts, it's basically teams that are communicating and relying on them. We are building an application that can be further passed to someone to deploy on a different environment, or to plug in a different database management system. So here is the beauty of working on such complex projects. And I've seen some questions already about this, and of course we will have the Q&A session later, but we have a few more slides to discuss some more theoretical things. Now, I think now you probably have a better overview on what a RAG application or a RAG architecture looks like, and I would like to summarize everything into a single RAG architecture schema. So there are, of course, many ways to draw this. I did not include here the infrastructure part, where we have the operating system or the cloud or the Docker images and containers that we are moving from an infrastructure support to another. But functionally speaking, on RAG, there is more than an LLM wrapper, definitely, right? And someone even asked if we can build RAG with a RAG with structured data. Of course you can, right? Actually, it is recommended to have within your application a persistency layer where you can store the history, you can store, your data, whether if it's structured or not, whether if you have JSON files or JSON objects, or if you have PDFs, or if you have any kind of objects you can think of. Embeddings works on any type of data. It's not necessarily you need to use text, right? This is like a use case that is very common, so that's why we choose it to demonstrate. But you can use like the traditional architecture of an application, of having persistence layer, of having lexical search here. And for instance, we can use a Solar engine that helps us to do some web scrapers and to identify some relevant parts of our data by performing lexical search, which are faster, of course, but not that efficient as semantic search. So we can combine them. Now, within the agent, of course, there are more things to be done than just wrapping the prompt with some context. We will need always, if we are discussing about enterprise applications, we need to always understand what is the context we are discussing about, and where are we in that conversation with the users, right? So we need a context selector. We need some modules to handle conversation status. We need translators modules. We need also modules to detect languages, and we can do that by also leveraging large language models or neural networks in general power, or we can do them by using traditional software development algorithms or traditional machine learning algorithms, right? So what's behind the scenes, it's actually, or can become, very, very complex. What we proved here is that we can build in a very short time very complex applications that can provide very nice accuracy, and then they can provide relevant answers. But when you want to go deeper and address very specific enterprise questions, there is much more you can do. And here, of course, it's like a good moment. We can say that for building a RAG application, we need more than AI skills and capabilities. So we need traditional software development capabilities. We need infrastructure. We need machine learning. We need Gen AI. Of course, so we need everything. We need databases in the sense of SQL or NoSQL databases or vector databases. We need interaction between the client and our agents, like REST endpoints or gRPCs or different protocols that we can leverage to transfer data, either uni or bidirectionally, right? So the story can continue probably infinitely. It's a very large discussion, but I think in only 80 minutes we already gained a very good overview on what are the opportunities and what are the possibilities, that the door that RAG is open to us. Of course, there are plenty of benefits of using RAGs, and most of them, like I'm highlighting this reducing inaccuracy in responses or hallucinations or LLMs. You probably heard about hallucinations. Now, if you provide better context to your large language model, you are reducing hallucinations, right? You can provide real-time and accurate data. You can provide domain-specific data, and it's very, very cost-effective. Moreover, you can reuse a lot of knowledge that you have existing in your team or within your department. You can combine with some new skills, and this is exactly how we do here at Cyclum. We are combining our existing skills, our engineering skills, with our dedicated internal Gen AI upskill program, which has the goal to upskill a large team of developers in order to be able to work with such complex and novelties, technologies and applications. Now, of course, we have a lot of possibilities, we have a lot of opportunities, but there are also risks, right? And this is why I'm inviting here my colleague, Mariana, who is the Principal Testing Center of Excellence. And Mariana can address us some words about what are the challenges, the new challenges coming in AI world now, what are the risks and how we tackle them, right? How we can tackle them. Mariana, let me please give you the screen, and you can go ahead.
Thank you. While I'm sharing my screen, thank you guys for the really nice presentation. We're slightly running out of time as in real world. So when there is a delay in development, we reduce time for testing, right? So my topic for today is to address some things related to how we test actually AI-based system. Now we are going to slightly revise software characteristics. We will discuss some risks related to testing of AI, and I will show you some methods and tools that can be useful to consider during testing and summarize with some balanced success factors. So let's start. Okay, so let's revise what do we know about software. In the classic world, prior to AI, we had very strict division on functional characteristic of the software and non-functional. I believe all of you should be familiar with this ISO product quality model. And when we need to test functional stability, we need to answer to the question, what does the system do? So basically, what are the features, what that are the functionalities, whether they work properly, separately, and combined together. And there is lots of non-functional characteristics, which gives us answer to the question how the system actually does it. So performance, efficiency, compatibility, usability, and the variety of LT words which we have here listed. On top of that, when we are testing AI system, we need to consider as well AI specific characteristics. That doesn't mean that we need to forget about our functional and non-functional testing. It means that on top of that, we need to consider new reality and new stuff that we need to keep in mind when we test AI-based system. So, for example, when we test flexibility and adaptability, we need to check how quickly our system adjusts and respond to changing data or conditions without any, I would say, extensive reprogramming or manual intervention. We need to keep in mind and check the system's autonomy, how autonomously it can make decisions and take actions independently without human oversight. We need to check how quickly system evolve and what is the learning process of it, how data-driven refinements occur. We need to test against bias as well. So how fair the outputs of our system, and so on and so forth. So there are a lot of AI-specific characteristics that we need to keep in mind, like ethics, side effects, reward hacking, transparency. And for people who are working in QA area, you most probably familiar with ISTQB. And thanks God, ISTQB released new certifications that is called AI tester. And if you are not such a person who collects certificates, I believe it worth downloading their syllabus and go through it, because the knowledge is very structured and it provides you with a step-by-step instruction how actually to start dealing with testing of AI. And I highly recommend it. I'm on the half of the book already, and I only can see benefits of it. Of course, with this new era of AI, we have a lot of risks, right? And the bucket of them is really endless. And here I selected just my subjective top 5 risks which dramatically impact our testing process and quality assurance practices when it comes to testing of AI. So first one is lack of transparency, which leads us to difficulties in designing of test cases, because requirements are not the same as in classic software engineering. Also, we have low interpretability, which is also challenging. We have ethical and bias concern, which leads us to unfair outputs, and the testing itself is quite complex to assess it properly against bias. We have dynamic learning, hence we have unpredictable system behavior. For example, whenever we run in classic environments some regression testing, we have expected result, and from cycle to cycle, expected result doesn't change much if requirements were not changed, right? So here we have constant change of expected result. That's why also we have as a side effect complex in update and maintenance of our test set, test documentation, and so on and so forth. And also as an outcome, we have loss of control, which leads us to impaired predictability, and it is hard to plan and to control our quality practices. And last but not least, as already today mentioned, hallucinations. I believe it's self-explanatory, but still we need to challenge our system to provoke, to generate hallucinations, and results here can be vague, unreliable, and misleading. So we have quite a lot of challenges here, but it is not so scary as it may look like, right? So when we have all the knowledge gathered, we can prepare the strategy, and at least acknowledgement of these risks also bring us nice results. We are prepared, we are ready, and potentially even we have some mitigation strategies to deal with them. Here I would like to outline some methods and give you some examples of tools that can be used during testing of AI system. I believe like 6 at least out of 10 testing types should be well known by everybody who is participating, like black box testing, combinatorial testing, exploratory, and so on and so forth. But here I would like to explain maybe 3 a bit new to our world testing techniques. First one is metamorphic testing, and here we actually validate the correctness of AI system via testing the relationships between inputs and outputs, while we have some knowledge about their properties and transformation. What does it mean? For example, whenever we testing some translation system, we apply those transformation to input data. Even guys already today showed you like how with the changing of some nouns with some synonyms can provoke correct and different output, right? So this is actually what this stands for, this metamorphic testing. Next one is transfer learning testing, and basically it verifies how effectively the transfer of knowledge or model of AI system from one domain goes to another. For instance, when we evaluate how well a sentiment analysis model trained on product reviews performs when it is applied, for example, to movie reviews. And we need to assess whether it adapts across different domains. And the third one, potentially less known as the rest, is robustness testing, is a subtype of security testing. And this technique is used to test the resilience of ML models against adversarial attacks, to ensure reliability and trustworthiness in the real world scenario. So this is not the full list of testing types, but according to a new ISTQB guideline, it is recommended to follow each of, like all of them, and keep in mind as a checklist whenever you test the AI-based system. And also here, I would like to highlight a couple of tools. So since modern world relied a lot of tools, and here in testing, we also want to rely on some tools tailored to the unique challenges of AI systems. So not sponsored. We did our trade-off analysis of these tools. We compared them and can recommend such stuff as Gretel, Ragas, and Giscard. They are really nice when evaluating, especially RAG application. They provide very good assessment against bias, against hallucination. Also, they provide some performance monitoring and even model drift detection. And to summarize from my end, what are the balance success factors? Maybe obvious, but as a QA engineer, you need to know the algorithm and you need to test the algorithm. You need to gain a comprehensive understanding of the system under test. You need to familiarize yourself with the AI system structure, with its functionalities, and based on that knowledge, align your testing strategy. And as an outcome, you will have more accurate testing and you will detect issues more effectively, I would say. Next, you need to make sure to have enough data because I think it's obvious in since AI uses machine learning, we need to work with large amounts of data, and in testing it as well. We need to have it on the right quality level. We need to be prepared to apply some data collection techniques. We need to have the right software for gathering data, and so on and so forth. And last but not the least, we need to bring the right people because they should be domain experts. They should be capable to understand the algorithm, and as well, you need to have a proper team composition. And as Lucian already mentioned, so this is not a single responsibility. The benefit here is to gather as much different expertise as possible. If you have such ability, for example, to involve security engineers, it will be super beneficial for you to have in a team composition. So this is basically everything what I have in this limited time slot. And I'm handing over it back to Lucian.
Thank you very much, Mariana. Maybe I would also have a question for you. So maybe we can quickly recap how we look at QA in AI realm. So now, as continually we are advancing in the field of this field of AI, particularly in emerging technologies like Gen AI and RAG. What are the new concerns, like summarizing the new concerns or unique issues that arise in the QA process, and how do we effectively tackle them?
Well, the list of challenges I mentioned before obviously is valid and accurate, and we need to keep in mind that maybe we can speak here a bit more about data privacy as one of main challenges when we test such systems. So users entrust us with their information, right? And it's our responsibility to ensure that the data remains secure and used in the proper way. And especially since we were talking today about these RAG applications, and they often involve interactions that require actual access to personal data. It can be conversational logs, it can be user preferences, or even sensitive information can be shared during conversation itself, right? So we need to keep in mind some kind of checklist to ensure that, first of all, user data is encrypted both in transit and when rested. We must test the encryption mechanism itself. We need to verify the robustness of authentication mechanism. Also, we need to keep in mind that RAG applications may accumulate vast amount of user data over time, and it is crucial that we have mechanism in place to securely delete or anonymize this data when it's no longer needed. And to summarize, failure to do so not only possesses privacy risk, but may also violate regulations such as GDPR or HIPAA or any others that are in place. Yeah. So that's kind of the one thing I forgot to mention today about data privacy.
Yeah, amazing. So it looks like things are can become really complex, and what is more important is that we are not actually really taking in serious the QA side, and even for our use case, I mean, we did not do that much QA because we prepared up front, right? I think it's worth mentioning. However, thank you very much, Mariana, for highlighting all the risks. And what is important, I think it's also it's clear now that risks are everywhere around us. But what's relevant is maybe to be aware that we have ways to tackle them. We are prepared to identify them, and there are a lot of techniques that that we can leverage in order to test or to prevent failures of or data leaking or data privacy issues within our AI applications. I believe now with the rise of Gen AI, especially, data becomes more and more centric than before, and it's very crucial how we cover our large, or how we isolate our large language models or our applications, and how we preserve the integrity of the data that we are storing. And now you also saw earlier that it can be much more than a simple LLM wrapper or RAG, or it can be even more than improving the context or enhancing the context of the query. But of course, context is very crucial and it's very relevant. And in order to dive deeper into this topic, I'm inviting here, and before we are wrapping up this session, I'm inviting here my colleague Maxim Litvinsky, who is the head of our cloud infrastructure platforms, and also very good expert in AI. Hey, Maxim.
Hello. Yes, thank you.
You can actually take the screen. Yeah.
Yeah, good evening to everyone. It was like amazing presentation, I would say, to all of the guys. It's really
Thank you.
Great. I will share full screen. So for sure, RAG part is quite important when we are working on the optimization of the large language model exactly to our use cases. But it's worth to mention that when we start this flow of getting the large language model and applying the capabilities for our application that we wanted to create and where we wanted to utilize the benefits of that, we always start from the first part, is from the prompt engineering, where we will craft the exact message and instruction for our large language model. Especially you saw today about the templates, messages, and messages for the assistants, because its influence on what the like basic behavior will be changed for the large language model or for the any Gen AI system. And only after like first start will we test our approach on the prompting and what is the reaction of our model. After that, we are going to the fusion prompting, where we provide the example of the results that we wanted to get from our model. And only after that, if we understand that we need to increase the actuality of the knowledge of the Gen AI system with what we integrate, we are starting to use the retrieve augmentation generation approach. And if we need to have like special utilization of our system that we built, like for example for the medical direction, and we need to have like certain behavior of our model, only after that we are going to the fine tuning. And we are starting. What is important to remember that we are starting from the smaller, from the easy part, and then if we understand that still we do not get the our baselines or our expectation in terms of model performance, only after that we are going to the next stage of the fine tuning of the model. Because basically, even like prompt engineer or RAG, we can name it as some type of the fine tuning of the model. We are like changing the behavior or knowledge that we have in the model. So prompt engineering, it's quite important. Even we had the discussion around the QA and prompt engineering. It can be the first your like guardrails in terms of secure the interaction with your model. I guess some of you know about the cases when some of the companies introduced the chatbot on their website, and basically that chatbot started to be as a free version of ChatGPT 4, where you can just ask any of the questions to that chatbot and get the answer and make it for free. So basically, what is the good prompt in general looks like? We always need to remember about the providing the role to our model. It's to the explanation of what they basically what the role it should play, and it helps to the model take some behavioral in terms of like answering, and it's kind of like some of the context. We should have like clear context on what exactly we wanted to have from the model. We always should have like instructions from the model, and we have some beneficial parts, but they always show the good progress on the expectation and performance that model provides. It's like additional formatting and examples. Exactly. So formatting, it's what the certain format we wanted to get as a response from the model or like our interaction. And sometimes it's good to provide the like exact examples. And what is good, it's provide not only like right examples, sometimes you can like provide correct and incorrect examples, and it will cover like additional part that's that cannot be like covered in your correct example. And from the like tactics, from the prompt tactics, we have some like basic tactics where we have this series of short prompting. It doesn't matter like 0, 1, 2, 3, and stuff like that. But basically, it's focused on the providing the examples of the format and examples how models should think basically in that short prompting. We can have the approach in terms of like model guided prompting. It's, for example, if we do not want to spend a lot of the time on the preparation of all details of the context, formats of the responses and stuff like that, and we just put in this responsibility on the model, where we are asking to the model prepare some like questions if it makes sense, additional question to get like the best result. And self-evaluation prompting that basically help to improve the end result that we are getting from the model. And model is doing the self-criticism on that, and it basically helps to improve the end result. In general, especially when we have like the new threats in the model and model starting to add like more guardrails, and sometimes we face that model is lazy, especially in the news we hear about that ChatGPT had the summer holidays or something like that sometimes. So the most part of the prompt tactics focus on the realizing the maximum computation from the large language models, and basically like on that computation, realizing of that computation, mostly focus different like thoughts tactics. I'm pretty sure that many of you knows about like chain of thoughts tactic, where we together with our request that we have to our model, in addition to get that full computation, we add in the magic words, let's think step by step. And this is the approach that calls, like in the GenAI world, give time to think to the model. and it helps to model to split your request in the certain tasks and try to solve this problem like with the step by step. And another good approach in the same direction of thought is thread of thoughts. So basically, we in the same way we are asking to go through step by step and summarizing and analyzing on that steps. So it's close to the same approach in terms of what the model will perform, but only with the difference where we have some kind of like summarizations on the each of the step, and in the end we are getting the final results. Both of these tactics they are helping in the more, especially like math questions, in some reasoning questions, where we need to get like more computation from our model. It's even sometimes can be compared with the people because we have its kind of like fast mind and some kind of the deep mind. So it's mean like, for example, when you drive your car, you already have reactions like switch on the lightnings, turn left or turn right. And this is like your already used to reaction, and you do not need to think deeply on what you need to do. This is like your normal reaction, and you use this like your fast mind. But if you have like some stress or fully changing situation, like I don't know, for example, your wife or some your passenger starting to ask you questions, you need to think on that questions if you are focusing on that, and then you are starting to use your like deep mind. And with the models, sometimes it works the same, and that's why we have many of the approaches that help to get that like deep mind and to push the model to utilize the full computation. So it's just like a short excursus in the world on the prompt engineer. We are planning to have more deeper session on that area. So later on, we will announce the exact date. And thank you all